Hello, everyone. So today, Dave and I will walk you over the new features and enhancements. So to get started, we'll go through the updates, what we have for .1 release. So I'll try to cover the pre aspects. So try to make the boring and intensive pre aspects a little bit interesting, and then later on they will add the colors to the present to this demo with the post demos and the slides. So for 2022.1, we added features in all aspects of pre and post processing, including the geometric modeling, AccuSolve setup, and meshing improvements. So let me go through the pre aspects, and then we'll hand it over to Dave to cover the post processing. So let's start with the geometric modeling improvements. So in this release, we added a ribbon called Sketch. So it will allow users to sketch 2D sketches, and then they can parameterize that, and from those 2D sketches they can generate the 3D shapes or model. It can be used for creating geometries like pipes, MRF region, which are arbitrary shapes, and then we have tools to convert those 2D sketches to the 3D shapes. The second improvement we added is the model organization update. So for large models, it's pretty tedious to review the model and organize them based on the simulation needs. So we made some improvements to that. So I'll go through that as well. Couple of tools which we added to interrogate into the model, as well as query some geometric details into the model. So those are find tools and query tool. So I'll go through them into the demo as well. And then we added some new geometry creation tools. So that will help users to create new geometries. So let me go through these aspects in a demo. So let me start with sketching. So let me load a simple model. So here we have this fan, and we want to create any arbitrary shape refinement zones. So as you see that when you invoke HyperWorks CFD, you will see there is a ribbon called Sketch, and it has the tools to define the sketching planes and create and tools to create the sketches and edit those sketches as well. So one of the few things is that you can create a new sketch plane by selecting a surface or directly defining a plane. You can create a sketch plane by projecting a surface to a specific direction, like in project, or you can if you want to take the reference of the existing geometry, then you can go to intersect. Here you can select the geometry which you are interested in, and then you can say that which direction you want to cut. So I want to cut into the center. So I'll select the center, and then I can switch the plane along the Y. So then it will show you the preview that how it will look like. And when you say intersect, it will take that as a reference and invoke the sketch plane with that reference. So now you have this cutting line as your reference. Then you can go ahead and create any of the with any of this tool and create your sketches. So I'll just quickly create a simple sketch. So here I can just start. You can zoom in and keep adding the lines. You can also specify the distance from the reference geometry as well. So if you want to constrain or add any distance to it, you can do that. So let me up. Then and even I can do any arbitrary shape or curved shape based on the requirements. And then let me just go to the and as soon as the lines are closed, you will see that region as blue. So that means that it's a closed loop. from which surface can be created. There are legends where if you want to add the constraints, so based on the definition. So right now all the lines are on constraints, or there are dimensions are not defined, but you can define the dimensions and some constraints for each of the line within the sketch ribbon. So it's pretty extensive capabilities. So it's a fully featured sketching ribbon. So once you are done, you can just press escape or exit out of the tool, and you can see that ribbon surface will be created. Now, in order to create the geometry, you can go to the geometry tool. There is a drag and spin. So here we want to revolve it. So I can switch to surfaces, select that surface which I want to revolve, define the spin axis. So I can zoom in and define that spin axis. And I want to rotate it by 360. I can just enter that value, and it will show you the preview of the newly created domain. And if you are okay with that, you can create that. So so this sketching will help you to create first a sketch, and then we have many tools to create the geometry. So another aspect is like if you go to the pull down, we also added some of the tools through which you can create the 3D geometry from those surfaces by dragging a line or surface along a specific direction or the normal directions, or even you can create the ruled geometry. So these are the new tools which we added in .1. So check them out. The help documentation is available for those with some demo models as well. So moving on, let me go through the next demo about the model organization. So when you have when you bring in any CFD model for the model preparation, first thing you want to do is to group that model. And this is what we see, that many users are using the group tools to group their model based on their meshing requirements, based on their geometric modeling requirements, or the meshing or setup requirements. So in this release, we have added few capabilities which will make the grouping task much more easier. So first is in the visualization mode, we have added the capability to review all these groups. So previously it was just the surface groups. So now you have the options to set the visualization color by either part groups or the solid groups. So let me switch to the part groups. So then you'll see that it will show you that how the parts are being grouped. So right now no part is assigned to any group. So to start with that, you can just select a part. And you can right click options, and you can say create a group. So let me call this as a mirror group and create that. So it will add that group and it will update the color. You have this show hide capability that if you want to hide anything, or if you isolate just unassign to work on those, then you have those capability as well. You can do you can keep creating the groups. So now I can click as tires and create. Once you started creating the groups, and then I can create this group for body. So once these groups are created, you can right click on any other part. So let's say I right click on this part, I select this part, the other few parts, and then you can right click and just tell them either you want to add them to the group. So that means that this parts will be added to the existing groups, or you can move them. So if move means that if they are part of some other groups, and if you want to only switch it to the specific groups, then you can use that. So now you can just say to tires, and all these parts will be added to that specific group. So you can keep doing that. So by mistake, if you let's say if you added this to tires, and now if you want to change that, you can right click and just say move groups to mirror, so that it will be removed from the tires and it will be added to that group. So this capability will help the users to organize the model pretty easily. They can just switch it to the groups which they are creating, and then using the right click options, they can keep adding or moving the items to the groups. Another thing which we added is like if you want few surfaces, so let's say I want this surface and this surface to move to a specific part. So let me then we have this right click options where you can also organize those surfaces in a specific part. So I can say move them to the body, and you can see that those surfaces will move to the body. And since those part are defined as the body, so those surfaces will get updated as well. So that is another capability which we added. On the top of it, if you want to review something, and those are pretty much hidden. So we added this options on the right click that you select the part, and if you want to see what is inside, you can right click and set the visualization to wireframe or UV lines. So that will make that specific part as wireframe. So you can quickly pick other aspects as well. So those are the capabilities which we improved to make the grouping, which is the first task which users do when they bring in any CAD. So it will help out to quickly create the groups and set up their model. So along with that, so let me just reset the transparency to everything. So along with that, let me talk about a couple of new tools which we added. So if you go to the home ribbon, we added this tool. Let me switch the color mode to parts. So in the home ribbon, we added two tools. One is the find. So find is a pretty useful tool to find out any specific geometries. So for an example, if you have parts and if you want to identify the matching parts, so we have this option that you can create a group, isolate them, or select them. So you can go ahead and if you want to select, you can select, then it will find it from those selection. If you don't, then it will do it from the displayed. And then you can just go ahead and say, find the matching part, and it will go ahead and find all the matching parts from the display. Some other options which we have added is on the surfaces side as well. So for solids, we added the options that you can find the connected solids, intersecting solids, self-intersecting solids, or proximity solids, or unmeshed solids. So you can identify what are the solids which are not meshed. And same goes for the surfaces. That we have a huge list of how many things you can find. So you can go ahead and say, okay, get me all the free surfaces, and you can just isolate them, and that will work on that. If you want to target on some specific things, so like you can make selection, and you can say, okay, only from that selection, get me all the intersections. So then it will go ahead and only find the intersections within those surfaces. So this is very useful tool to find specific geometries and continue with your modeling. So if you have a lot of topological issues, if you want to find out what are the so even for the meshing side, what are the surfaces which created intersecting elements or duplicate elements? So you can use this find tool to go through that. The another tool which we added is the query tool. So that is useful for. So let me first mesh probably a surface. And just mesh with ridge body, define as 20. Okay, so now in the home ribbon, we have the query tool. So what query tool does is that if you select a part and you say compute, so it will go and fetch all the information related to that selected part, like what is the ID, the area of it, how many surfaces are there, solid counts, the element count, and the bounding box dimensions. You can also query from the solids or surfaces. So like you can select the surface, and you can find out what is the area of that surface, how many elements are there, part of that surface, and bounding box. Some important aspects, like if you have, let's say for an example, if you want to find out the coordinate of a node, then you can select that node and you can work on it. Another use for this query is that, let's say you ran into a simulation where it is giving you the BC warnings from Akisol, and you want to identify those nodes. So you can select this nodes by IDs, and you can paste all the IDs, and it will give you what are the surfaces attached to those nodes, and you can isolate those nodes. So this will also help to debug any of the issue. So these are some of the updates onto the geometric modeling. So let me move towards the physics setup. So in physics, one of the requests which we got from the field was to add the capability to define the boundary conditions using the scattered data. So within the advanced boundary condition, we have added the options that you can define select a field, let's say XYZ velocity or pressure, and you can define those fields using the scattered data. So it's pretty straightforward. So let me just quickly show you a demo. So if you go to the flow ribbon and boundaries and advanced boundaries, so here you can select, let's say I select this advanced surface. I can select, I want to define the X velocity, and you can set the type as the scattered, and then the values for it. You can also open any of the value. So you can open any of the text file or CSV file, and if you have those data, you can bring those in and define your setup. This has been improved to bring in a huge number of data sets as well. So once it is done, then your scattered data. Same thing has been exposed to define the mesh, the motion boundary as well. Another important feature which Akisol team added is the hybrid mesh motion, that if you want to, so previously if you want to use the mesh motion, you mostly start with the MRF and then map the data to the next simulation and do the mesh motion, or do the simulate using the mesh motion. For that, since restart is not working, the user has to go through the hassle of running the MRF simulation with MRF, extract the results, project it, and then run the mesh motion. So now we have a hybrid mesh motion capability where user can, so let me open a simple model. So user can go ahead and set up their simulations and then define like what is the fraction of the MRF and what is the fraction of the sliding mesh motion as a part of the setup. Okay, so for this, user can first define the transient simulation. So here you can physics, you can define this as transient, you can define the time step size, and then go to motion and set up this as specified. Then they can directly go to select the solids and surfaces and define the axis of it. And once you do that, the dialog will pop up the options about the hybrid. So within the hybrid, you will identify what is the size. So you can say 170 radians per second and how you want to define the varying motion. And then you can add the rows to define like how the MRF fraction. So that means that what percentage of the rotation is covered by MRF and what percentage of rotation is covered by the mesh motion. So let's say from the step 1, it is 100% MRF. So you define it as 1. From 20th iteration, you want to reduce it to 0.4%, 0.6. So 60% of MRF, 40% of sliding. Then you can keep adding that how it will ramp up the simulation, and then at the end it will be after 60th iteration it will be 100% MRF fraction. We also had added this compute option. So if you want to get the time increment scale, so you can automatically calculate it, that how it can ramp up the time steps such that to transition from steady to the transient simulation. So so this is the step, and then when you internally it will write out the MRF, the mesh motion, and relevant time step increment for that simulation. So this is pretty easy to set up, and this will remove all the hassles we have to uh, go through the mapping process, at least for the for switching between MRF to sliding mesh motion. Another feature which we have added is to define the effectiveness into the porous material. So with that, it will enable you to simulate the temperature dependent porous medium, and this is one of the documentation, the tutorial file which Xol team has prepared. And very tiny item is we added the options for defining the surface tension in Eulerian multi-phase interaction model. So now you can also simulate the contact angle with that. Moving on to the meshing improvements, very tiny few improvements. So first, we supported the parameters for the refinement zones. So now you can define your model. You can set up all your refinement zones, and you can define the parameters as the refinement size as the parameters. So that is being supported. And then another options, option to in the volume control, we have added the options to propagate the size to surface mesh control. So previously, user has to define a separate surface mesh control and volume mesh control. So now with this, if you are defining specific size to volume mesh control, this will automatically propagate it to the surface mesh control. So those are some tiny improvements, but it will help a lot with the process and workflows. Just to remind you, we have self-training training material, a lot of tutorials and how-to videos, and also we have some of the industrial applications. So if you haven't checked it out, please check it out. And we have added some new tutorials for this release as well. And for next releases, we are targeting some of the robustness improvement, adding the light representation for the large model handling, some meshing improvements, and also we'll be working on the property editors and units and some template manager updates for the next releases. So with that, let me hand over to Dave.
Okay, we will start in talking about Post. Okay, so Harsh gave you a little bit of a sneak preview of some of the things that we added in Post on his opening slide. And I'm just going to dive into some more details of each of these items as we go through today's presentation. So for 2022.1, we actually added a whole lot of capability. So some of these come in the form of new features entirely, new contexts, new tools to work with, and some of them are just expansions of existing capabilities. And I'll detail these as we go through the slides. So the first new feature that I want to talk about is the ability to set preferences when reading data into HyperWorks CFD Post. So this is one of the features that has been requested for quite some time now. And the most common use case for this is when you're reading AccuSolve data, people want to be able to access the extended output variables. So things like derived quantities, running average, gradients, time averages. In the past, it was a very cumbersome workflow to access those. So you had to create an AccuSim CNF file. You weren't sure where that file was being read from. So we've added this new option now into the GUI that allows you to set some of these preferences. You don't have to have this reader options dialog pop up every time you read a data set. So it's controllable. You can dismiss it and tell it to disappear forever if you like, or you can have it popping up at each import. So we're really just getting started with the different options that we can support here, but we've split things out into two different collections of settings right now. So we have settings that are general in nature, and these are independent of what file format you're reading. So for example, when we load a transient data set, whether you want us to show the first step or the last step by default, or what's your default display style. So right now, or in the past rather, we used to just show the boundaries of the model in gray. Now you can fine tune that a little bit, and you can have them displayed by some variable, or you could still have them displayed as gray. The second collection of settings that we have is some that are specific to the readers. So right now we only support options that are specific to the AccuSolve log reader, but this is where you'll see options associated with which collections of variables you want to read and some of the options associated with mesh motion are in there as well. So I'll actually demonstrate this feature, and we'll see what it actually looks like. So I'll pull HyperWorks CFD over into my shared screen here. And I'm just going to say File, Import, and then I'm going to pick an AccuSolve log file. So I'll go grab this mixing elbow model, which is a pretty good one for demo purposes. So I'm going to pick on the log file. Now you see that this reader options dialog popped open before it actually imported the data. And under the general options, I can set the default display to be the first or the last time step. This isn't a transient, so it doesn't really matter. And I'm going to have it display temperature by default. So when I click import, it's actually going to show me the temperature on the model by default. I don't have to go through and actually assign those temperature settings to the boundary display. And for the AccuSolve log reader, I do have specific options that I can turn on. So you can see that I have derived quantities turned on. So I'll just leave that on, and I'll click on import. And now it's going to go off and it's going to read the data, applying those settings. So now the first image that you see is the temperature on the model. And it's just a nice time saver. So the user doesn't have to actually go through and select the boundaries and then set it to display the temperature. So we can continue expanding on this. We also have the ability to control the default display of the boundary collections, and whether it's the surface outputs or the boundaries that are visible. So lots of additional capability that we're going to add in the future to this. So that was the first new feature I wanted to talk about. And the next one I want to talk about is something we call surface warping. And this one's actually one of my favorites. It's a new display style that we didn't have access to in, say, in AccuField View when that was our primary post-processor. So we are starting to add some capabilities that are actually new to our post-processing workflow, and this is one of them. So the way it works is you select a surface, and right now we only support this on boundary surfaces and slice planes. We can expand that, but I wasn't sure that it really made sense for ISO surfaces. So we kept it to boundary surfaces and slice planes. And what you do is you basically select a vector or a scalar that you want to deform the surface by, and then you set a scale factor. And once you set that, we actually warp that surface by that local scalar or vector field to give you an indication of what the 3D representation of that field looks like. So in the image that I show here on this slide, I've created a slice plane, and then I've warped that slice plane by the velocity magnitude. And it's a really nice way to visually inspect the uniformity of that field on the surface. So for example, you can see that where I have this high velocity, the dark red, you can see that is pushed forward in that image, indicating that the flow has a higher velocity there. You can see that it's kind of a local jetting region. And then you can also see some of these other high velocity regions, and then some of the low velocity regions are as shown as deformed less. So this is a really neat feature. I use it all the time. It's particularly useful for internal flows, but even for external flows, it has some value. So a couple notes about this. If you're warping by a vector field, then we're going to displace in the direction of the vector. If you're warping by a scalar field, then we have to set the direction somehow. And we base the direction on the surface normal. So it's one of the things that you'll need to keep in mind. So if you're warping by a scalar, there is going to be a little bit of sensitivity to what the surface normal is on the surface that you choose. So if you don't like the direction that it displaced by, then you can just set a negative vector or a negative magnitude rather for the displacement amount. So let me demonstrate that feature. And this is actually a pretty handy data set to do that with as well. So I'm going to hide some of my exterior surfaces. I'm just clicking on them and then using the H key to hide them. Now let's create a slice plane. So we'll create a slice plane in, let's see, what's a good direction here? We'll go here. And I'll just calculate that. Okay, so now we've got a slice plane. And you see we have this option of warp. So I'll move my dialog a little bit here. And let's actually warp it by the velocity field. And you can see the default is the velocity for the vector. And it warps for me. And now I can scale that up. So I'm just going to roll my mouse wheel and then hit enter. and I can scale it up to a higher value. So the slice plane that I chose is kind of boring because the flow is fairly uniform as it enters here. But you can get an idea what the boundary layer profile looks like, so you can see the shape of the boundary layer here. And also you'll notice this is a conjugate heat transfer case. So if I change the display to be temperature and then set it to be local, you can see that in the solid region, I'm not getting any displacement. And that's because the velocity is 0 there. So the region that's solid isn't warping at all, but the region that has the fluid region is displacing by the local velocity vector. So this is a really nice feature. And let me actually adjust that plane a little bit, see if I can get it into a more interesting spot. So if I move it over to here, then we calculate it there. Yeah, so here you can start seeing some of the greater asymmetry developing in the flow as it progresses from the inlet here and starts to turn to go up that other side pipe. So really nice feature, and it's a new capability that we didn't really have previously with AccuField View. Okay, so the next feature that I'll talk about is vortex core calculation. And the vortex core calculation is a calculation that we can run that'll display the center of rotation of a vortex structure as a line. So this feature is really useful for identifying any type of a recirculation region that you might have in your flow field. So obviously, that's one of the first things that you're looking for. Whenever you're doing any post-processing, you're typically looking for regions in the flow that have recirculation or higher levels of rotation. That allows you to investigate how much mixing is going on, or if you have a low pressure region. So this tool is a really nice way to get that first quick look at what the flow field is doing. So a lot of times I'll run this first, and that'll give me an idea of where I have some activity in the flow. And then I'll start using my slice planes, my iso surfaces, my streamlines to further interrogate the flow in that region. So the input to this tool is a velocity field. And that velocity field can be the instantaneous velocity field, it can be the time average velocity field, or the window average velocity field. So depending on what you're interested in, whether it's the instantaneous results or these time average results, you can choose which velocity field you feed to this vortex core calculation, and then that'll give you a different result. And once you have these vortex cores, then you can do some things like creating streamlines from the core of the vortex. And that's exactly what I've done here. So you can see that the vortex core kind of passes through the center of this recirculating region. And it's a little bit tough to see because of the transparency, but those streamlines outline that rotational region and that recirculation. And that's all done by just knowing where that vortex core is, and then that helps guide you as to where to put your streamlines. So if I wanted to see the size of the recirculation zone behind these little pillars, I could have grabbed this vortex core, put some streamline seeds on that, and then that would have allowed me to really outline and highlight that feature nicely as well. So I do have a little bit of a note down here. This calculation can be pretty expensive for large models. And when I say expensive, we're talking on the order of 30 seconds to a minute for really big models. So it's not horrific, but it can bog you down a little bit. We can improve this, I think, a little bit more in the future. So if we end up getting a lot of use out of this and there's demand, then we'll take another look at it. But let me demonstrate it on this model. So what I'm going to do is I'm going to turn on the pipe walls again. Oops, there we go. Okay, so we've got our pipe walls turned on. And I'm actually going to make this guy transparent here. So let's set the transparency. So we'll just multi-edit these things, and we'll set the transparency, and we toggle the highlight, so it's a little bit easier to see. Okay, so those surfaces are now transparent. We can see inside the flow field a little bit better, and we'll dismiss that. Now I'll just click on vortex cores. And the input I said is the velocity field. So right now we're just going to look at the average velocity, since how this is a steady state simulation. And I'll just click on calculate. It's going to go off and think for a second. And now you can see that it's outlined, or it's calculated the center of these vortex cores for me. And I can color them. If I want to color them by the local velocity magnitude, or if I want to color them by the local pressure, I can do that. And you have some controls over the display of these things. So you can increase the tube radius if you want. So again, I'm just rolling my middle mouse wheel, hit enter. That makes them a little bit larger. So if you are going to put streamlines on them, it's a little bit easier to pick once you've done that. And we can just check our work a little bit here. So let me create a slice plane, and we'll put the slice plane in a location that passes through those vortex cores. So there's a bunch of vortex cores up here. So we'll put our slice plane in that area, and we'll calculate it. And then what we'll do is we'll turn on the vectors on that slice plane. So we'll turn the vectors on, and then we'll set them to be projected. Oops. So we'll set tangential vectors, and then we'll increase the scale just a little bit. And we'll zoom in. And let me change my local legend here. Yeah, so now if we zoom in, we can actually see that our vortex cores pass through the center of where we see these rotational vortex structures in the velocity field. So it's just a little bit of a check of how well the vortex core algorithm is doing at actually identifying the vortex structures. And it looks like it's doing a pretty good job. And we can actually subset the vectors too. And then that helps to illustrate a little bit better. So a really nice tool for interrogating your results. A very quick way to identify the bulk features and the bulk behavior of the flow field. All right, so let's jump back to our presentation. New and exciting here on the next slide. 2D plots. Okay, so 2D plotting is a new feature that we've added in 2022.1. And we've actually got quite a few plotting capabilities coming in future releases. So this is really just the beginning of what we can do. So stage one for us was to be able to do line plots that are sampled from the volume. So the way this tool works is you enter into this context and you define a rake, what we call a rake. So this is really just a line of points on which you want to sample the results. And what we do is position this line in the appropriate orientation, the appropriate locations. You tell us how many points you want us to populate along that line. And then we go off and we interpolate the solution from the volume onto those points. And then we create a plot so that you can see the spatial distribution of that field that you've plotted. Once you've created the plots, there's quite a few controls over the display style of the plots. You can export the image. You can also just export the line data. And some of the kind of the neat features that we've added to this is that you can show and hide the plot from idle. So you can keep the plot on the screen. And as you sweep in time, we'll update that plot for you so that you can see the evolution of this field as you progress through time. So let me do a demo of that. And the demo I'm going to do isn't going to do this justice because there's really a lot of capability here, but I'll just show some of the basics. So I'm going to turn that surface off. And let's see here. You know, it might be interesting to actually plot right along this slice plane that I created. So let me start hiding a couple of surfaces so it's a little bit easier for us to get in there and work on that slice plane. And I'll hide the vortex cores, and I'll just set our view to be perpendicular to this. So yeah, it might be neat to actually do a plot across here to look at what the velocity field looks like. So I'm going to enter into my plot context. I'm going to click on rake. And then I can pick on the surface. So I'm going to pick that point, and I'm going to pick this point. And now I've got some nice tools here. So if I want to make sure that this is perfectly aligned with the Z-axis, I can just click on Z, and that aligns it. And then I also have the move tool available. So if I click on the center of the rake, I can move it around. So I want it to be roughly centered. If I wanted to position it precisely, I could click on the origin of the move tool, and that would pop up some input for me. So I'm happy with this position of the rake. Click on seeds. If you want to add more seeds to it, you can. So I'll just type in 100. And then we can click on calculate. Let's just take a look at a side view here, make sure it's where we want it. Looks pretty good. So I'll click on calculate. And like I said, it's going to go off and it's going to sample the results in the flow field. And then it's going to create this plot. So I can set the plot to be of the velocity. And here you can see that we have high velocity kind of near the walls where we have this recirculation that dies off and it becomes less in the center. And let's actually set it to be, let's see, what way is the flow going? Flow's going in Y. So let's actually plot it versus the Y component of velocity. Yeah, there we go. So we have basic plot controls as well. So I can set different display parameters if we want to be circles, dots, triangles. I can adjust colors here. So let's set it to black just for fun. And then we can zoom in interactively too. So I'm using my middle mouse wheel to actually zoom in. As I hover over it, it's giving me the information at the given point that I'm hovering over. You can reset the zoom just by hitting the reset button here. And you can also plot versus different quantities. So if you wanted to plot versus, let's say, Z, then you can do that as well. You can rename the plot. So let's call this velocity plot. And you'll also see in my model tree that it updated the name there as well. So if we're happy with this plot, we can simply accept it and exit. And by default, when you enter back into the idle context, we hide the plot. If you want to see it, then you just toggle the visibility on. You know, we do have a little bit of a quirky behavior on Linux. So I'm doing this demo from Linux, where the sizing isn't quite right on the first display. But once you resize it and then show it again, it keeps that sizing. So some other neat capabilities here. I can right click and I can export the data. I can export the image. And it's just a nice way to really interrogate your results and get results out of the solution. And you can dock this as well. So you could keep this docked. Or, I'm sorry, not docked rather, but present on your screen. So you can resize it. And then you could stack up a whole bunch of plots here if you wanted, so that you could all so you could see them all at the same time. Okay, so that's it for the 2D plotting. And let's go back to our presentation and see what else is new. Okay, this is another fun feature. So the next feature that I want to talk about is the changes that we've made to the legend and color map controls. And we've really added a lot of nice capabilities here. So in the past, we had some very, very basic controls for legends and color maps. We've extended them significantly in this release, and we're going to continue to extend them in the future releases. So color map controls, you now have control over the title and text of the legends. So the names, the labels, the number format can be controlled, and the position and orientation of the legend has much more control as well. So we'll pop back to the GUI, and we'll go through that a little bit. So I'm going to hide this plot just to kind of keep it out of the way. And let's operate on this slice plane. So I'm going to turn the legend on, and let's take a look at velocity on this slice plane instead of pressure. So I'm going to look at velocity. I'm going to turn my legend on. So you can see that my legend shows up by default in the bottom right corner. I can now change that. So if I go to display, and the first thing I might want to do is move that guy. So I can just grab the move tool, and I can put it anywhere on the screen that I'm interested in. And when I'm done, I'm just going to hit escape, and it's going to kick me back to this dialog. I can make the legend horizontal, and then I can put it in predefined locations. So you can see there that I just click this icon, which centers it up at the top. I can also play around with the color bar thickness. So I can set it to be 24, and that's in pixels. And then the length of the color bar is exposed in screen space. So now it's 50% of the screen. You can also control the format. So I could set the labels to be bold. I can choose different fonts. We've got size and precision controls here as well. And you can change the whether you want floating point or exponential. I can also customize the title. So if I want to say velocity in meters per second, for example, so I can add some units to that. And then obviously I can control that with bold, highlight, or I'm sorry, bold, italics. We also have shadow. And then you can align it to the left, right, or the center. You can also change the color. So if you want it to be red, for example, you could do that. So lots of nice controls now over what you see with the legends and the color maps. And there are more capabilities that we can add to this, but we'll continue adding as we get more requests. And we'll go back to our presentation now, and we'll see what's next. So we've made a lot of improvements when working with transient data. So this is an animation that actually isn't playing for some reason through my PowerPoint. Let me see if I can get it to play some other way. Yeah, here we go. So this, oops, it's not going to work. But basically what I was showing with this animation is that I have two data sets loaded. and they have different output frequencies. But when we sweep them in time and we play that animation, we can actually see that both data sets are advancing. And you'll see that one advances at a slightly different rate than the other one was. But the idea here is that we can manage fairly complex situations when it comes to performing animations. So in addition to being able to handle those complex cases, we have faster sweeping in general. So if you have a single data set that you've loaded and you sweep it in time, it's about 2 times faster in this release than it was in the previous releases. We also have time versus time step selection for sweeping controls. And now we do have the ability to annotate time. So you can see in this slide, I have the global time shown up here as 0.003 seconds. So let's take a look at how that actually looks in the user interface. Let me try playing this animation outside of the presentation. Yeah, here we go. So you can see that the global time is advancing in this animation. And what you'll see is when the motion of that bar starts, yeah, there you can see it. You can see that they're not both advancing at exactly the same rate, and that's because they had different output frequencies. So this is really an asynchronous output interval. But when we animate it, we have this concept of a global time, and we try to keep both data sets synced up with that global time as well as possible. Okay, so now let's take a look at the transient data set. So I'm going to clear this session, and I'm going to load up a transient data set this time around. So if I say import results, so we'll load up the H3D file, and I'm going to have it go to the first step by default. Okay, so here's our data set, and let's just scroll in time real quick to see what's going to happen here. So here you can see that the model starts to deform, and we get some oscillation of that bar. So some of the new capabilities that we've added are the ability to display the time step, or the time rather, instead of the frame number. So if I click on time, now I can see that it's no longer the frame number that's shown down here, but rather the actual time of the simulation. So I can advance, and as I advance in time, you can see that time counter is increasing as well. So that's a capability that's been requested quite a lot. We also have the ability to add the annotation. So if I go to my notes context, I can put a note, let's say right up here. And now you can see that I have time available as a field. So I can say time equals, and then I'm just going to click on time, and I'll say insert field. And that displays the global time value of the current post-processing session. And you can play around with the precision of this. So right now, the precision field is set a little bit high. So oops. So I'll just set it to 3. And that just gives us 3 decimals. And of course, you have control over this guy as well. And if you want to move it, you can. So let me move it up into the top corner. And that's good for that note. So now as I advance in time, you'll see that time value is updating as well. So those are some of the features associated with the time stepping. And there was more work that was done behind the scenes on this, but those are some of the highlights that I'll talk about. And let's see what else we have on the list here. So just some general enhancements that aren't necessarily worthy of a demo, but we've got better point sizing in new contexts. So in the past, we were always sizing the points as a function of the model scale, and that doesn't always work all that well, so we've improved that. Same thing for the streamlines. So we've really improved how the streamline default sizes are set. As a result of the plotting enhancements, where we're updating the plot at each time step, we've also gone through and updated our integration and point probe results at each time step. And we've added snap points to faces of the box clip, and lots of bugs were fixed as well in this release. So let's talk about some of the things that are coming next. We're working on intersection curve plotting. So that feature will be available in .2. It's actually just about to go to QA right now. Engineering quantities calculator. We've got our first implementation of that ready. This is a feature that's been requested quite a lot. So people are interested in computing mass flow rates through surfaces, or pressure drops between 2 surfaces, temperature difference, things along those lines. So we've got some really nice workflows that make that very easy. So those are coming up. 2D surface streamlines. These are features that have been requested for both UFX and AccuSolve output. So we've had a number of clients that are requesting those. And information and properties mechanisms currently being worked on, so you can get some information about how many points or how many elements are on a given surface. And we're going to continue enhancing these feature detection workflows that we started with the Vortex cores. And then particle tracing is also on our horizon. That won't make it into the next release, but it is one of the things that we're working on. We've done a lot of performance improvement that didn't quite make it into this past release, but it will be in the .2 release. So exterior face extraction, if you're interested in displaying a solid as opposed to displaying just the boundaries of the solid, we've got about a 10x speed up on that. Clipping is much faster, about 6x faster. Surface streamlines are about 80x faster. Point probing is faster. And then surface normal calculation is also significantly faster. And we're always working on usability improvements. So we've made a few improvements to preview planes and how we render them and display them and select them. So you'll see that coming in the next release as well. And just to summarize, 2022.1 is really a very competitive post-processing solution. I didn't focus a whole lot on performance and speed, but I'll assure you that it's extremely good. In many cases, it's substantially faster than our previous solutions. And it's evolving really fast. So you saw a whole lot of new features that were displayed today and demonstrated. And there's more in the pipeline that just didn't quite make it. So I think you'll be pretty happy with the feature set that we actually deliver in the .2 release as well. And yeah, we really need your feedback. So use it. Tell us what you think about it. Tell us what you like. Tell us what you don't like, and help us to guide this development. And that's it from my side.